Today, we are diving into one of math's coolest secrets. Seriously, it's a pattern that's so simple and so elegant, it honestly feels like magic.
No, I'm serious. Have you ever seen a number that can actually do magic? Forget card tricks. We're talking about a number that can literally rearrange itself in the most incredible way. Let's meet the star of our show. Okay, here it is, 142857. Right now, it looks pretty normal, doesn't it? Multiply it by 1, you get itself. Standard stuff. But just watch what happens next. Now let's multiply it by 2. We get 285714. Hold on, take a closer look. Do you see it? It's the exact same digits. They've just shifted. The 1 and the 4 just moved to the end of the line. The magic is starting. Let's try it with 3. And, yep, there it is again, 428571. The same group of numbers, just starting from a different place. It's like they're all holding hands and spinning around in a circle. At this point, you could probably guess what's coming next. Times 4, and we get 571428. This pattern isn't just beautiful, it's perfectly, amazingly consistent. And again with 5, 714285. Those 6 digits are just dancing, taking on new positions every single time, but the group never changes. And finally, let's multiply by 6. We get 857142. The pattern holds all the way to the end. It's a perfect, complete cycle. Just incredible.
So what is the deal? This isn't some random coincidence or a weird party trick. There's a really deep and fascinating mathematical structure at play here, and it even has a name.
So let's go ahead and crack this code. Let's figure out what makes this hidden dance possible.
Our star number, 142857, has a special name. It's what's known as a cyclic number. And all that means is that when you multiply it, the digits don't just get scrambled, they rotate. Each new answer is a cyclic permutation, which is really just a fancy way of saying the numbers are spinning in a perfect circle. So if you wanted to test another number to see if it has the same magic property, the process is pretty straightforward. First, you pick your number. Then, you just multiply it by 1, then 2, then 3, all the way up to its number of digits. For our guy, that was 6. And the last step is just to check. Is every single answer a perfect rotation of the original?
You know, a great way to think about this is to picture these digits arranged on a wheel. Every time we multiply the number, it's like we're just giving that wheel a little spin. A different digit lands at the front of the line, but the order of the numbers themselves never, ever breaks.
But wait, there's actually another layer of magic here, and it all comes down to the number 9. Check this out. If you take any of those results we just saw and add up all the digits, something cool happens. Take 285714, for example. The digits add up to 27. Now add those 2 digits together, 2 plus 7, and what do you get? You get 9. This is called the digital root, and for every single one of our numbers' rotations, it's always 9, always. Okay, so this is way more than just a cool number puzzle. These kinds of predictable yet complex patterns have some surprisingly powerful uses in the real world.
Take cryptography, for instance. A simple code, like a Caesar cipher, is static. It's predictable, which means it's pretty easy to break. But what if you used a cyclic cipher? You could use the shifting pattern of a number like ours to create a dynamic key that changes constantly, making your code way, way more secure.
And it doesn't stop there, because these numbers are all about repeating patterns. They're super valuable in data compression. That same reliable cycle makes them useful in the mind-bending world of quantum computing, and even in algorithms that check for errors in data to make sure everything is transmitted correctly.
So where does this all lead? Well, these numbers aren't just a modern curiosity. They're a part of a much bigger, much older story about patterns and discovery.
And this is really why this all matters. Our fascination with these kinds of cycles is ancient. You can see similar patterns in things like mandalas and old artwork. Today, we figured out how to use them in our technology. And, looking ahead, researchers are exploring if they can be used in AI, or maybe even to help us analyze the complex sequences of our own DNA.
It really brings to mind this quote from James Joseph Sylvester. Cyclic numbers are a perfect example that math isn't just about cold, hard calculation. It's about finding the hidden harmony, the elegant rhythm, the music that holds our universe together.
And that kind of leaves us with a final thought, doesn't it? We've just uncovered one beautiful hidden pattern today, but it really makes you wonder, what other secret dances are happening all around us? In numbers, in nature, in the cosmos, just waiting for someone to notice.